gives me 6, right? Because we'd have to do the distributive property to multiply this back out. Well, 2 times 3 is equal to 6, so I must be left with a 3 here. Well, I've already taken out my a, and I didn't do anything with that b to the 8th, so we still have b to the 8th left, right? And that would be my factored expression. Okay, let's look at our second one. Okay, well this one, in our two terms, because remember a term is a bunch of things that are combined by multiplication. So we actually have two terms here. And both of our terms have a z plus 3 in them. So that means I can factor out a z plus 3. And now I want to write what we have left. Okay, so let me write this for the first one too. So the 2a is what was factored out. And in the parentheses is what we have left. Okay, so similarly for our second example, the z plus 3 is what is factored out. And now in our parentheses we're writing what's left. So if I took z plus 3 out of my first term, well, I see I'm left with a 3x there that we haven't done anything with. And now I bring down my plus sign. Well, if I take z plus 3 out of my second term, what do we have left? Okay, this is where you need to think about what number is really outside of the parentheses if we don't have anything written there. It's that number 1. Okay, so we really have a 1 left when we factor out the z plus 3. Another way to think about it, you're asking yourself, what do I multiply z plus 3 by that will give me the z plus 3 I started with? And that number is 1. If it were 0, that would make it drop out completely, and we wouldn't have our original expression. Okay, next we want to look at factoring trinomials with leading coefficient of 1. When doing this, there's a two-step process. The first step is you want to find two numbers that multiply to equal the constant on the end. Constant just means number. And secondly, these two numbers have to add up to the middle coefficient. These are the numbers that will go in your parentheses. Okay, so a trinomial will factor into two binomials. If you think about the FOIL method that I had written on an earlier page when we were multiplying two binomials together, you'd remember that first times first should give us that square term. So r times r gives us r squared. So that's our easy part. Well, next, using this two-step process, I'm looking for two numbers that when I multiply them together, it gives me the constant 12. And when I add these same two numbers together, it should give me the coefficient in the middle, which is -7. Okay, well, I know I'm going to have some negative numbers since I want to end up with a -7 when I add them together. However, when I multiply them, I'm going to come up with a positive number. Okay, so that tells me both of my numbers are going to be negative. So if we look at a -3 times -4, that gives us a positive 12. -3 plus a -4 equals a -7. So those two work. So that tells me that those are exactly the numbers that will go in my parentheses. And that would be my factored expression. Okay, going on to part B. Okay, so our first step, if you remember that first rule I gave you, whenever factoring, you want to factor out any common monomial factors, if there are any. Part B, I'm realizing we actually factored out a binomial, but that's okay. So we should just put factor out common factors. They don't have to be monomial. Any common factors, if there are any. So for this problem, notice 7 is a common factor. So if I factor out a 7, I'm left with an x squared, plus we're doing the reverse of the distributive property. What times 7 equals 21? That's 3, and we still have the x. What times 7 equals negative 70? That's negative 10. Okay, so the 7's going to stay, and I know that that trinomial can factor into two binomials. The first times first gives me x squared, so I know I'm going to have an x in both of those slots. So now I need to know two numbers that multiply to equal the number on the end, negative 10, but they need to add up to be the number in the middle, which is 3. Okay, so if they're multiplying to give me a negative, I know that one is positive and one is negative. Okay, and since they're adding up to give me a positive number, I know the bigger number is going to have to be positive. So if we try a 5 times negative 2, that gives me negative 10. 5 plus negative 2, same as 5 minus 2, gives me a 3. Okay, so we'll have a plus 5 and a minus 2. And that would be our factored expression. Okay, so those were trinomials that had a leading coefficient of 1. Okay, part B, after we factored out the 7, we had the leading coefficient of 1, so we could use this two-step process. Now, if you have a trinomial that does not have a leading coefficient of 1, the two-step process does not work for these. And what you're going to have to do is use trial and error and check with FOIL. Okay, so for our first problem, factor the trinomials completely. Okay, well I know my trinomial will factor into two binomials. So thinking about FOIL, the first times first should give me 15x squared. So I know that I'll have an x in each of those first slots, but they're going to have coefficients because I need my numbers to multiply to give me 15. So I'm going to try a 3 and a 5. Okay. All my signs are positive, so fortunately we're not going to have to worry about any negatives in this problem. And now when I do last times last with FOIL, I know that my numbers should multiply to give me a 2. So 2 times 1 is 2, so we can try our 1 and our 2 here. Okay, well I don't know that this works. We need to check and see. So the way that we check it is by using FOIL. So first times first, 3x times 5x squared, times 5x is 15x squared. Outer times outer is 6x. Inner times inner is 5x. Last times last is 2. So we have 15x squared. 6x plus 5x is 11x plus 2. And we see that that is what we started off with. So we got lucky and picked the right combination. Now let's say that this did not check out. Then that means that you would need to switch your numbers around. Maybe it would have been a 3x plus 2 and a 5x plus 1. And then you'd have to multiply it out and see if that worked. If that didn't work, then maybe you would need a 15x and a 1x. So you just have to try different combinations until you get it to check out. Okay, so with part B, again, our leading coefficient is not 1, so we're going to have to use trial and error. Okay, so I know that I'll have a y and a y. So I need two numbers that multiply to give me 8. Okay, so we may try a 2 and a 4. Could have tried an 8 and a 1. Okay, lastly, I need two numbers that multiply to give me a positive 9. So 3 times 3 is 9. But notice that the sign in the middle is negative. So somewhere a negative is going to have to be introduced to the problem. Well, both of these terms would have to be negative because if they were opposite signs, that would give us a negative number on the end. Okay, so this is what we can try. So we have to check it. So first times first gives us 8y squared. Outer times outer is negative 6y. Inner times inner is negative 12y. Last times last is plus 9. So we have 8y squared. Combining our like terms does give us our negative 18y that we wanted, plus 9. Okay, so this does work. So that would be our answer. Okay, the last thing that we wanted to look at in this lesson is simplifying a rational expression. One polynomial divided by another polynomial is called a rational expression. So an important note when simplifying them, if you have a plus b over a plus c, do not make the common mistake of crossing out the a's and saying that this is equal to b over c. This does not work. If it does, it's an exception to the rule. However, when you're dealing with multiplication, then it is okay to cancel out and it would equal b over c. Okay, so as long as you have a product, you can cancel. If you have a sum or a difference, meaning subtraction, you cannot. Okay, so let's perform the indicated operation and simplify. So for part A, we're just adding two fractions together. So if you look at the first page of our handout, when adding fractions, you have to have a common denominator, which we do. So we just add our numerators together. So we get 7 plus 4, which is 11, and the denominator does not change, stays x. And that's it. Going on to part B. Okay, so for this one, we just want to simplify. We're not adding anything together here. So to simplify this, what we need to do is factor the top and factor the bottom, and then hopefully we can cancel something out using this rule that we just went over up here. Okay, well in the top, since we have a leading coefficient of 1, we're looking for two numbers that when I multiply them together gives me 5, and when I add them together gives me negative 6. Well, the two numbers that will work in this case would be a negative 1 and a negative 5. So that means the top will factor into x minus 1 times x minus 5 divided by. Now in the bottom, notice we have a common term that we can factor out, and that's 4. So if I factor out of 4, what times 4 gives me 4x? That would be x. What times 4 gives me the negative 4 I started with? That would be negative 1. Okay, so notice that everything that we have now is multiplied in the top and in the bottom. So we can apply this rule up here. So I can cancel out my x minus 1's, and that's going to give me an answer of x minus 5 over 4. Okay, last for part C, okay, we want to subtract these two fractions. So to subtract, you have to have a common denominator. So one way to get a common denominator is by multiplying the denominators together. It's not necessarily the least common denominator, although it will be in this case, but it's something that will always work. So to get a common denominator, you can multiply the different denominators together. Okay, so in this case, our common denominator is going to be x plus 2 times x minus 1. So to get that with my first fraction, what I'm going to have to do, so we're starting off with 3 over x plus 2. To get my common denominator, I have to multiply both the top and the bottom by x minus 1. Okay, well, why do I have to multiply the top by x minus 1 as well? Well, that's so that we don't change the value of the expression. Because something divided by itself is equal to 1, and if you multiply something by 1, it's just whatever the something is. We don't change its value. Okay, so that's why we have to multiply by the expression over itself. Okay, then we have a minus 1 over x minus 1. To get our common denominator, I have to multiply this by x plus 2. So I also have to do that in the top. Okay, so now this is going to equal, in the top, we'll have 3 times the quantity x minus 1 divided by x plus 2 times x minus 1. Then we have a minus 1 times the quantity x plus 2 over x minus 1 times x plus 2. They're the same. The order doesn't matter. 3 times 5 is the same as 5 times 3. Okay, so they're still the same. All right, so now that we have a common denominator, that means that we're just going to subtract the numerators. Okay, so we have our 3 times x minus 1. Then we have that minus 1 times the x plus 2 all over x minus 1 times x plus 2. So now in the top we need to make sure that we distribute. So in the first term we're distributing the 3, and then we'll have to distribute that negative 1. So we end up with a 3x minus 3 minus x minus 2 all divided by our common denominator. Okay, so our last step is to combine our like terms. So we have 3x minus x, and then we'll also be able to combine our negative 3 minus 2. So that'll give us a final answer of 2x minus 5 all divided by x minus 1 times x plus 2. And you can leave your answer like that. You don't need to multiply the denominator back out.